From this point on, I'm going to record the webinar right now, and then I'll send you a copy to it so that you can watch this over again if you'd like. So what we're going to do is we're going to track all these points. The obvious way to do it is to come into 2D tracking, enable 2D tracking, and then we can define a region. So I can define a region around this point and set that region, and then I can have the software track that. And it'll track it down here, and then it gets lost, which makes sense because it gets lost as it strikes the surface. It can no longer find it, and then it bounces off. So I can reset it again if I want to on the other side, and then track it through the next few frames. That's pretty straightforward, right? So now I'm just going to do a few quick things to give this a real world value. I'm going to right click on the video, or I can also hit Tools and go Modify Recorded Parameters. This is an animation, so it doesn't have any record rate. When you're pulling video from the camera, you'll need to write this down or whatever. Let's pretend that I recorded this at 500 frames per second. Again, there's nothing in here. So I'm calibrating it now. I just calibrated it based on time, and now I want to calibrate it based on distance. So I'm going to hit the multi-plane calibration. I'm going to come in here, and I'm going to pretend, and I don't know again, I'm going to pretend that we know the width of the field. We know that that is 1 millimeter. I'm going to apply that scale. Okay, so now I've just done a quick calibration. I can come in here and graph information about my point. So let's look at the speed of this point here. So this is an output graph of the speed of that point that we just measured. Now it's got a fake spot in here, and that is going to likely be the occurrence of this spike. So I don't like these values in here. So I'm going to come up into my delete mode. I'm going to select those and delete them. So we'll just completely remove them. We'll go into manual mode, and I'll interpolate the difference and make the software sort of guess about the bounce off the surface. Now when I come back to my graph and I refresh the data, I've got a great new set of data that shows the speed of it. And you know, it always stays positive because it's not a vector velocity, it's the absolute velocity. So these are the values that I'm getting. I can show and visualize the values that I'm seeing in the graph here by clicking on this little button over here that says Display Legend in 2 sizes. And then when I just refresh it, I'm getting values here. Oh, it's still in pixels per second. So I have to come back into 2D and tell it I don't want these units in pixels. I want it in meters per second. And then it updates that there. Or I could say, hey, now give me this in kilometers per second. And it'll update the values as such. Okay? So in meters per second, here's the calculated values that we're getting in the graph. Now, if I want to, I can come in and right-click on this graph, go into my graph menus, and I can export this displayed data to a text file, to an Excel file, an Excel template, or a C3D file. So if you want to export this data set into MATLAB or something like that, this is how you do it. So you'd save it as a text file. That makes sense. And then here's just a raw set of the data for that single point. And column 1 right here is the index. So this is the frame number, essentially. Column 2 is the time index that we've calculated here. And column 3 is our speed that we're calculating. And this is in meters per second. So that would be quite a time-consuming way to go about doing this. I'm going to remove this line from I'm going to remove this line from my graph and just close my graph for a minute. So there are better ways to go about doing it. I'm also going to turn off my 2D line. The problem we're going to encounter in this case here is this black or this white bar at the bottom. So the first thing I want to do is I want to filter that out. I don't need to do any image processing because it's already black and white. It could not be better, and it's obviously like that intentionally. So I want to do some image filtering. I'm going to add a simple filter where I just mask out that bottom. There's a bunch of ways that we can mask out an area. That's not super important right now. Just know that you can do it. If you need help with that, there's a whole section of the manual that will do this. I'm going to use what's called a zero border function, which just draws a little border around the whole screen, and I'm going to edit that. And I don't want any border on the left, I don't want any border on the right or on the top, and on the bottom I want, so if I put my reticle over here, it's right in around 442 vertical pixels. You can see down in the corner here. This gives the information of where the reticle is. And so I don't remember, but I'm guessing if it's 442, I probably made that bottom like 60 pixels high. Yep, I probably did. So now I've just quickly filtered that out. Now what I'm going to do is I'm going to open up the particle tracking toolkit. Turn the thing back to the beginning. So I'm going to enable the particle tracking toolkit. We can use the whole screen if we want to, which I'll do in this case, or we can use a region of interest and draw a little box and say, tell me all the particles inside this box. I'm not going to do that today, but this can be a very processing intensive toolkit. So sometimes if you click it and do the whole screen, it's going to take you forever. Like for instance, I did this on the video that you sent me yesterday, and I queued it up to process, and then I just went home. And when I came in, it was done. And you'll see the results of that in a minute. Here are all the settings of this. So I can set minimum sizes. When it's at -1, that means there's no minimum size. But I could say, don't show me any pixels, any blobs that are under 30 pixels in size. So if there's like a bunch of like spray and tiny single pixels going, it'll count individual single pixels. If you don't want to do that, you'd set that. Or also, the other thing is if there's a big blob that you wanted to ignore every time, you could say, don't show me anything over like 3,000 or whatever. But the defaults are -1 and -1. There's a whole bunch of settings in here that exclude and filter things out, including the angle of objects. So if you have something really oddly shaped, you can exclude those, or the angle of their travel, or the eccentricity of the object. So if you want something that are pure circles, you can do that based on altering the eccentricity values here. But what I'm going to do, because this just works, is I'm going to leave these default values and tell it to look for white particles. And then I'm going to let it track. And I'm going to sort of distract you over here while that processes through. So this is finding all white objects in the field and is giving exact XY location data for each of these objects and information about the eccentricity of these objects and the size of the objects and the directionality of these objects and whatnot. And I think this is probably what you're going to be using most of the time for your applications. It's got about 5 frames left. Okay, there we go. So now I can go in and I can look at information about any of these objects that we've discovered. But what I can also do is I can also come down to our graph now, and I can graph information based on those particles. So I can get information about the number of particles. So if I graph this, this shows me the number of particles in the field at any given time. Don't care about that, so I'll remove that. Or I can get information on the size of those particles. I can get information on the angle that those particles are tracking or their speed. So let's look at the average speed of all the particles in the video at any one time. So this is the average speed, and it's in meters per second, or it's in millimeters per second. So if I change this to meters, there we go. So that should be roughly what we were seeing with the other pixel. So that's the average speed of these objects. Okay. Now the other thing I can do at this point, is I can, let me close off my graph. I can start pinpointing information about individual specific particles in here. And the way I do that is through a thing called Correspondence Trails. So right now the Correspondence Trails are off. I'm going to turn the Correspondence Trails on and just play this video through. And this is the program trying to follow and track those points as they exist and identify the particles in upcoming frames. Right now, all the correspondence trails have question marks on them because I just generated them. But I'm going to right-click, scroll down to particle trackings, and I'm going to ask the software to recalculate those particle numbers. Now, each individual particle, in essence, is numbered, and it has attributes based on these particle tracking numbers. Okay? So if I want to look at my initial first one here, this is number 1. This is that one that I initially tracked there. So what I can do in the software now that I've got all these particles numbered, is I can start to dig down and get specific information about these particles within the software. So let's go back and look at particle number 1, and I'm going to show you how to do that here. I'm going to come back into 2D feature tracking, and I've got my particle 1 information that we captured in 2D tracking already here. I'm going to turn that off. I'm going to add another item to track by clicking the add button, and then I'm going to go into the wrench and edit some attributes of this particle. And what I want to do with this particle is I want to make this what we call a virtual point. So I'm going to click on set for virtual points. So this is a way that we calculate and bring in data from different points and different toolkits and bring them together. So I can bring in a 1D point that I've calculated and bring it into my 2D tracking and get information about it in that way. So I'm going to come down here, click from particle tracking, and I'm going to get information about correspondence trail number 1. I'm going to apply that. So this is the path that the object was created if we look at it in terms of how the particle tracking tracked it. Okay? And if we look at compared to the red dot, it's almost virtually identical. You know, it's actually probably more accurate because the green line goes off the very center of the object. So now that I have that point in 2D, now, whereas before I was getting averages and whatnot, I could only get the average speed of all the particles at once. Now I can add an object, and in 2D, I now have this feature 2. So now I can get my speed of feature 2, which is just this individual particle. And this is it. So it bottoms out here because it doesn't exist, but this shows my speed of that. Okay? And I can turn off my average one. So this is the speed over time of that individual particle. And I can do that for any number of particles. So I can add another one and look up one from virtual point. I don't even know what one this is, 16. There's where 16 goes. I can add one and find out information about point 23. And it'll do that one. I can add a virtual point and find out information about, and I could just keep adding them. 44, there's where 44 goes. All right, does that make sense? And so I can get specific velocities. Where's 44? There's 44 as it goes up here, about individual specific particles or just information about the particles as a whole. In this instance, all this motion, it's all bouncing perpendicular to the camera. So it's traveling like this, so we can get velocities. If these objects were coming and bouncing and heading towards the camera, first of all, their size would be changing, but you wouldn't be able to measure the velocity based on the center of them if it's coming towards the camera, unless you're calibrated a plane that is traveling along, like we discussed yesterday. Do you guys have any questions about this? Does this make sense?
Yes.
Okay. And again, I'm recording this. There's a lot of steps in place. I'm going to record this and I'm going to send you this specific file because this specific file just works and you'll be able to play around with it. I'm going to close that information here so you don't care about that. I'm also going to very quickly, because this is important for your video, but it's not super vital for the thing. I'm going to throw up this video very quickly and just talk about it. This is a toolkit that you do not have currently, but it might be useful. So one of the things I noticed when I was going through the normal video, so this is the T3 video. Here's the T3 video, is that right in here, you experience a shock wave that affects the camera, right? And when we begin to track all these particles, you see all the particles jump up and down. One thing to consider, and you don't have to do it, but you might want to consider it, is we have this ability to smooth out the video. And so in this instance, I've stabilized the video, and you can see there's a little black bar at the top here that surrounds it. This is sort of like the buffer bar. And what it's going to do is, this video had a very small portion in the lower right, which was not affected and which didn't blow. Pretty much everything else moved or was obscured at one point. And based off just this area in the bottom here, I was able to take the video and stabilize it. So now when you play it through, it doesn't have the jitters that it had before. And we're looking at the explosion without the effect of the shock wave hitting the camera. Okay? So now let me go back to this normal video. So the goal, go ahead.
How did you stabilize the video?
Okay, good. All right, I'll show you here. I've actually already got it pulled up. The way I did it was I processed the video like this, and I broke it down, and I'll show you how to do this, into essentially like this. And you can see it rocking there. But I've selected 3 points which don't move. And I get the software to track those 3 points which aren't moving. And then I tell the software, make these points static and have the rest of the video rotate around these points. Does that make sense? So as these points are moving, all the software does is just keep these points stable here. And instead of rocking back and forth like that, it allows everything else to be stable so that it basically subtracts this shaky motion here, which we can pick up from these objects in here, because these objects shake back and forth the same. It's just hard to track it because those are moving. Okay? And so I just track these points here, and I stabilize the video through that. And then I resaved the stabilized video. Okay? So, with that said, let me go through the process I did, or sort of like the secret recipe hidden inside here for how I got to the second point. So the first thing I did was I made the video very contrasty, with lots of contrast between all the particulates flying through the air and non-background particulates. So these are lit basically by light, and the other parts are scattered in the background. So I brought the video to this point. And then I turned on, yes?
Excuse me, yeah. Can you go through the whole process of the stabilization?
How I got there? Yeah, but yes.
Yeah.
I am going to take a quick picture of this, though, so I remember where the settings are, so I can cheat afterwards. All right, so this is how it starts off looking, right? The first thing I do is I turn this into black and white, because I don't care about that. And then what I start doing is I start playing with these slider bar settings. Let me turn off my stabilization, because I don't want those bars down the corner. All right, so I start playing with these slider bars. What I generally want to do is I want as much contrast as possible, but I want it as bright as possible. So I sort of just bend my contrast and pull this. And whatever I set these will determine what point of the rock explosion and how much detail I want to get out of it when I come back to capture it. So when I did this, I was focused on the main part of it in here, because that was the best part that provides, honestly, the neatest sort of motion, directional motion like this. But after I had done, I noticed that it hadn't gathered information about this area up in here, because the lighting is different in that area. So if I want to focus on the scatter of particles over there, I would, I'd do the settings a little bit differently. And there's no like perfect way to do this. Like, I've messed with this a lot, so I know how these settings work. Really, the best way is to just slowly adjust it till it's at the point that you like it. Now, the interesting thing is you could theoretically not touch the video at all, and you could set all the particle tracking settings to understand this without setting this, so that it would already find the points that we are going to find. But you as a human would spend so much time trying to fine tune it on that end to get the software to understand it, that to come in at this point and visually adjust it is way, way, way easier. So it is theoretically possible to do exactly what we're going to do here without ever touching the image processing or filtering settings, but this is going to be a lot more work for you. So, let's say I leave it like right about there. I don't know. That's a little bit darker than I had it, but that's fine. It'll still get a bunch of points. Now what I do is I came in here and I turned on what we call a threshold. And because of my previous settings, I had it way lighter. This threshold is way, way, way too dark. So I want to turn this down. And I just adjust this at points. And so all this is doing, let me turn on my histogram. And then let me turn this off. This is a histogram showing the pixel, dispersion on the shot. I'm going to actually redo this again to show you. So when I have it normally, the video is sort of outlaid like this. You have this 0 represents a completely black pixel, and this 255 represents a completely white pixel. Your dispersion of this shot is pretty much in the middle here. So you aren't getting any dark blacks and you aren't getting any bright whites here. You're using a very narrow field of your imager when you take this shot. So if you had adjusted the shot previously so that your histogram is spread out more, you in effect have more information to work with inside your video. So what we do is, the first thing I do is I turn it to black and white, and all of those color variants just disappear because there's no such thing as color anymore. And then as I increase the contrast, what it does is it does this thing we call combing, and I'm just going to increase it here. Increasing the contrast is just taking those pixels, and it's in the exact same shape that we saw previously, and it's just stretching them out, and it's putting more space in between each of those pixels. The effect looks like things are darker and lighter. So I guess the best thing to do would be to pull it so that we're approaching the white end of the histogram spectrum and the black end of the histogram spectrum. Okay? So when I had those settings, I set it sort of something, I had it something like this, I think. And these gamma and log functions sort of alter it. I think I had it something like that. Okay? So now what I'm going to do is I'm going to come in here and I'm going to turn on my image filtering. Again, this is the exact same shape. What I've just done is I've stretched out the pixels so that they're farther apart, and I turned on this exponential log function here, which does the effect of stretching out the bright end of the histogram. So whereas initially the whole thing was pretty much straight up and down here, I've now bent it so that there's a lot of pixels crushed in on the back end or the dark end here, and then I've stretched out the light end because the light end is where all these points are that we're going to want to see. And the light end of this shot is where we're going to want to play with this thresholding. So now what the threshold is going to do is it's going to ask me for a value in here. Right now I'm telling it the value of 55. What this is going to do is this is going to find pixel number 55 on my histogram, and it's going to split the histogram right there. And it's going to say everything above 55, you're white. Everything below the value of 55, black, which is essentially what I want to do. Let me close that. So if let's turn this on and apply that. So I've split it now. Now my histogram looks ridiculous. There are only 2 lines in it because there are only 2 options. Everything is stacked to the 0 or black, or everything is stacked to 255 or white. And again, I can toggle this on and off, and you can see it. So as I lower this value, 44, 44, 44, it shifts the point where that break happens on the histogram, and now it's saying it's allowing darker things. It's just bumping them up to white. So what I want to do by doing this is I want to find the perfect value that it separates the video exactly how I want it to find the particles. And there's no like specific way to do this because the value I select here depends upon exactly how I slid these bars here. But the general idea is that you want to pick a point on here that shows you what you want to see. Okay, so like I said, this setting here is focused mainly on this mass exploding from this point. it doesn't show me anything up in here. I'm not getting any values up in there. So if I look at my raw video, so again, this is all happening as an overlay. The raw video is always underneath. So if I look at this area here and I want to pull information out about this mass here, I can do that, but I just have to alter values. So I have to come in here, let me turn this off. And this is way, way, way darker. So I have to turn my settings way down. Okay, well, not too. So maybe like 22. That's too much. So maybe there. So if I want to study this area, I have to alter the values to get that. And then there, now I can study the velocity of those objects. Okay? That was a super fast way. If you missed some of that, that would be understandable. Like if that went a little bit too fast, I get that. Now the next thing I did was I have a mess of stuff like this. So this represents, if I look at the raw, this represents what looks like a whole bunch of individual particles, but I've taken it and it's just a mass. So I have a filter that's called break connections. What's happening here is there's light bending in between and sort of joining two objects so they look like they're the same objects when in reality they don't. So I have a filter in here that when I turn it on, it sort of cleans up any lost things. And if there's a little break, like right in here, that's probably two objects. It says, I think that's two different things. And it just breaks it up. And it makes what previously was a big mess of objects into something much neater. Okay? And it's also removing all these single pixels, which I won't want to track. So the end result is I have something that looks like this. Now I'm going to revert this because I did tracking. Like I said, I went home and I tracked this all last night. So I'm going to revert it to the settings I tracked last night. But if I wanted to, I could track it based on this. So for instance, let me pause it at this frame here because this is a nice frame. I'll come into my particle trackings. I'll turn it on and I'm going to use a region of interest. I'm going to say, let's look at this area right here. I'm going to set that region. I'm looking for white particles. I don't want anything that's under 12 particles in size, so don't give me any single pixels. And it's going to pick up this huge mass, which I'm going to call not a particle or not something I'm interested in. So I'm going to say, don't show me anything over probably 2,000. I'm not sure. And then I'm going to hit this middle button, which just tracks this single frame. And again, I'm not doing the whole thing, but what I've now done, so here's the data for this individual frame in this individual box. And it's giving me information about each of these particles. Now, some of them I'd ignore. Like I would absolutely ignore this one up here. I don't like that. I don't count it as a particle. It already ignored this one. And I kind of would like maybe this one. So I would have to alter the values on this here. But as is, this is decent for what it is. So this is giving me information about all these individual objects, and I can look at their size. So this says size of 90. That means there are 90 pixels within it. We have not calibrated the shot again. So this is just giving me pixel size information. But if I had calibrated this shot, it would be telling me that this size was 90 millimeters or meters or centimeters or whatever value you were doing it, 90 centimeters squared. Okay? This doesn't mean that the volume is necessarily 90 centimeters. So I don't know if this is a round ball or a flat surface. We can't tell because we're only looking at it in 2D. right? If you look at my phone, like here, it could be a cube, and it's going to say it's got a huge volume. But if my phone is flying by and it's on end like that, you're going to think it's got a tiny volume. So the size is based on the view that you have. Okay, so that is how that works. I'm going to disable this. I'm going to completely close this, in fact, and I'm going to reopen it with the settings that I used last night. I used the exact same procedure. It's just the likelihood that I got everything exactly the same is low. Let me turn off this graph because it means nothing. So here are the settings that I did in terms of this, and here are the results that I got when I captured the whole thing. So thousands and thousands and thousands of particles flying through the air. Okay. And when I come in here to particle tracking, again, I could turn on the correspondence trails. So this is information about every object under these settings that is visible. So I can pick up information about the average speed of any of these objects, or I can come in here like we did before and say, I want to find out information about 1789. And then I can just come in, and I've already got all these other particles lined up here, but I can add one. I'm going to turn them all off except for this one and say, show me information about vertical point 1791. I'm going to apply that. I'm going to convert it to a real point. This just doesn't lock it with the calibration, with the particle tracking. So now when I disable the particle tracking and I look at my thing, this should show me, where did 1721 go? Oh, it reset it. That should show me information about 1721. Anyways, so here are information about individual particles that I picked out of that last night. And again, you could track these manually like I showed it before, or you could just import information from the file. So here is tracking this object. So if we look at the raw shot, that's that. It's really hard to even discern as an individual rock piece, but as we process it down, it's clearly a chunk of mud or rock or something accumulated together. And let me just look at the current one. So this is the motion path of that object as it goes through here. And likewise, there it is. So here's a whole bunch of objects. So I could take the information about this point 1, and then I can graph it. So let's add it. This is feature 1. I can find out speed information or acceleration information on it. So I'll just look at speed. So here's the speed information for that object. Okay. And it's really jaggedy, so I'm going to come in here. I'm going to turn on a filter. We've got a little filter button that you can click. I can enable it, and I can add a smoothing filter, for instance. So then that takes that value and it smooths it down, and it's giving me this velocity value in pixels per second. Okay? And I can also look, and you can see these jitters here. These jitters are in the shaking of the camera. Like this represents when the shock wave hits. You can see these if I graph out a whole bunch of these, like feature 1, feature 2, feature 3. So this is the thing that sort of necessitated the image stabilization. I typically would have done it before, but I don't want to be too pushy on that sort of thing. So when I filter all these, we'll be able to see the shockwave points. Enable filter, add a filter. So now when we look at it here, we can see all these dips represent the movement of the camera as it's shaking and as the shockwave hits it. So the other interesting thing to see is I could also do an FFT for all of these objects. And let me just turn them off except for one. So this is a quick frequency grab of the object. So it shows embedded frequencies inside of the motion of the object. So these frequencies here would represent motion frequencies or vibrations if the object is shaking or trembling as it goes. Okay? So now, if we had this all calibrated, it would be as simple as here's the velocity of individual objects, or here's the overall velocity of everything in there. So let me just enable and load my particle tracking again.
Overall velocity, combined velocity of all particles.
So again, these would be the values that we're looking at here. So here's the overall velocity of everything, and here are velocities of individual items. But again, like I said, and the interesting thing is I picked velocities of all objects within a specific region, or speeds, mind you. So everything in that region is within the same sort of velocity. The overall velocity is way lower because we've got all these outlier pieces that are flying and they are out of axis and they're not calibrated to the same shot. So they're likely going at the same velocity or similar velocities. It's just they're out of plane of the motion. And so we wouldn't take those into consideration. Does that make sense?
Yes.
Okay. So this is the point where I'm going to sort of step back and say, all right, what questions you guys have from this point on? And how can we work at it? Because I've got maybe another like half hour that we can do together, and I want to make the most of it. I could show you more examples if you want, or I can give you more theoretical slides, but probably the most useful thing would be to answer questions that you guys have.
Excuse me, Patrick.
Yes.
Can you show us a movement in multiple planes? If we know distances in three planes, three directions, so can we decide movement of particle based on two planes, maybe multiple planes?
Yeah. Great question. How am I going to do this? Well, first of all, so let's say I'm going to completely turn off my particle tracking. Particle tracking is important to get the information, but I'm going to turn it off right now. And I'm also going to turn off this information, and we're just going to deal with these rocks and these points as they're tracked here. And that's appropriate enough for, oh, I've got an annotation. All right, that's appropriate enough for the thing. So one of the things we had talked about yesterday was maybe putting in a bunch of spikes and whatnot so that you could pick up calibrations from different areas. So you can calibrate multiple points using different calibration methods. So let's come in here and let's look at, let me find one of these points. They all sort of come, anyways. So let's say point 1 comes from here, but beforehand you had placed something in the ground right in around there that you decided you wanted to use. And what you can do is, let me show you something. Let me do something here. I'm just going to save a single frame of this video. So what people will often do, and they do this all the time with 3D calibrations, but there's no reason why you can't do it with a 2D calibration. And this should open right up, but it might not. Okay. We've got a couple of things going on here. What people do with the 3D calibration is they'll set their camera up and then they put a calibration fixture in place. Just a minute. They'll replace this 3D calibration fixture within the area they're looking to measure. Now, this specific fixture only works with multiple cameras because it calibrates an area, and I don't think you should specifically do it, but you could certainly use the technique they do. So, oh, it's still saving. I'll save that whole thing. Bear with me a moment. I'm opening up too many things. So what they do is they take the shot, they don't move the camera, and then they calibrate based on that shot, and then they bring the video in afterwards. So what I would recommend, that's fine. I'm going to call this calibration. So I've just taken a still shot from one of those things. I'm just loading up something here. Oh, actually, this is really good. I've already got a bunch of stuff loaded up that I can show you. Okay, so here's our shot that we're going to work off of. And I'm going to show you another shot. So I've also worked recently. Come on, open a recent file. I just saw that file. I also worked recently with a university in America here that's studying horses. They're picking up horse motion. Where's their information? Here it is, University of Georgia. So when they're doing it, they set up something ahead of time and they take a still shot that never moves. In this instance, they had a bunch of cones in place, and they calibrated a 3D space around these cones. And then they don't move the camera, and then they remove the cones and they do the shot. So if and here's another shot. So these are all points that they calculate ahead of time, like this. And so we feed this into a calibration or calibration calculations, which you could do in ProAnalyst as well. And you could come up with multiple angle calibrations. So for instance, in here, you could do a calculation that goes, it does a perspective calibration from the top and bottom of this cone here, and then it goes out to here and out to here and there. And that's a known value. So if you set those up in the field and you have any explosions that are happening along this axis here, that's coming in this direction, then you know velocities of that. Okay? And likewise, let me turn on my little highlighter over here. If you have something, you could calibrate based on the top and bottom of this cone, and then the top and bottom of this cone, and you know the distance between here, you know this distance, and you know this height. So any motion happening along this plane, you would be able to calculate, and you'd be able to use that. So if there was a rock down here that exploded and landed over here, then you know it's within this plane. And maybe even if it's slightly outside of that, you can still get pretty accurate numbers based on that. So if you were in here, what I would recommend doing, let me set this up, give it some weight, is if you set up a bunch of poles like this ahead of time, and each of these poles has little points on them, sort of like this, that are at a known distance, you can use these poles as calibration points for the shot. Like this. Okay? When I come in here, let me save as a calibration. That's perfect. Yes, replace it. Okay. So now when I come back in here, I'm going to open up this calibration, and I'm going to use the calibration from this other shot on this video. Where'd this go? Here we go. So I drag my calibration in here, and I've got this shot. So then let's make a couple of calibrations up here. Let's make a couple of perspective calibrations. So this one here will go off point 1. Let me see. No, I got to think of it this way. Set point 1, 2, 3, 4. And I'll leave those values all as 50. And we'll apply that. So that'll be, let's say these are 50 centimeters. So that can be one calibration. I can add another calibration for an object over here. And you can add as many of these as you want. I don't believe there's any limit to these. But this would be your best bet for doing this. And we said that was centimeters. Okay. Yes. So I've got these two calibrations. So when I come in here into my 2D feature tracking, wait. So I'll save those. So now when I come in here to my actual video, I can load up calibrations that I had captured from my previous file. Where did those go? Did I not save them? Okay. That didn't work. Where did I might have just deleted yeah. So if I have calibrations that I can save here, let me quickly do these again. Sorry. So point 1, 2, 3, and 4. And this will be calibration top or whatever. That's in centimeters. And let me add another calibration, another perspective calibration for point 1, 2, 3, 4. This will be calibration bottom. Centimeters. Apply that. I can save this now, which is a step I didn't do. So now I can come into this video, which is the exact same scene, and I can load up my calibrations that I calculated from over there, and they're in the same position, except the rods have been moved. So now when I come into 2D, I can assign different calibrations to different objects. So if I say I want number 1 to use the calibration, I can have number 1 use the top calibration. And so all the velocity values for this will be output in that perspective calibration here. And I can have number 2 use the bottom calibration. And if we did all the calibrations correct, all these values will be relative to each other. You know, I can do calibration 3. Okay. So then when I output all the values, it's going to all be different. So I refresh that. So all the values have changed here now. So if, I don't know, obviously the best solution is like that video I showed you the other day of the explosion. Let me see if I can pull that up really quickly. Where we were sitting, the camera was looking directly down at the explosion and everything is happening perpendicular to the camera. If you can set up the shots like that, that is ideal. However, I know that that's, you know, that's not always going to be the case. The other option, the other option that I was thinking might work for you is oftentimes, let me see if this video will load up really quickly. Oftentimes we do aerial shots now because drones are so cheap. So we'd do an aerial shot like this. And then in this instance, I just did the calibration based off of spacing, known spacing between lines here. But you could do a grid mark out on the blast area. And then if you throw an object over top, that would work here. And so in this instance, I just flew my drone up and captured my car driving around. And what I did was I stabilized the shot because the drone is shaking back and forth a little bit. It wobbles. So I just removed that wobble back and forth by stabilizing it. And, you know, I can extract motion like that. So that may be another way to do it. Because this way, you're definitely, all of your motion is in plane as it goes out like this. The trick with this one is getting, you know, a high-speed aerial shot with a drone. You won't be able to probably get the type of camera that you're using on the static shot up on a drone. But let me see, where was the other explosion? Yeah, this one here. So this one here, like we looked at yesterday, let me turn this off. I think this is sort of the gold standard, or what you should strive to do, but I understand that that's not really realistic here. And so in this instance, they're spraying this up. There's not a lot of chunks because it's mostly a surface explosion, but we could still locate and track these objects here if we just alter and play with the gamma here, sort of like that, right? And then I can come in here, add a filter, add a threshold filter, and just find the right threshold point. There we go. And now in this instance, I want a black particle within here. And then there, I can get information just like this on the explosion of this object if it had more particulate in it, and then I could track the outliers here. Okay. So aside from that, what more would you like to see come from us? Do you want more of an explanation of any of these features or anything like that?
No, no, actually, you told us about calibrating two different planes.
Yeah.
We we have the blasting block we have, and we know the size of the block, but the particles don't fly in particular 90-degree angles, right? It can fly in between also. So I was thinking if we can calibrate according to two planes, and then it can give us any mean information about the flight or the velocity of that particle.
So, so we're looking for particles that are going. If you are calibrating this, let me get rid of all these. If you are calibrating this based on this flat known area, we can calculate. Let me add a perspective one here. So,
and we also know the depth.
Sorry, can you cut out there? What was that?
And we also know the depth.
The depth?
The depth of the patch. Yeah, the height. Yeah, the height of the patch.
Okay. So you know this size. I think yesterday you said this was like 6 meters, was it?
40.
40?
No. 6 meters. 6 meters of height.
Yeah, it matters, but it doesn't really matter. Okay. So for this, we can calculate lots of stuff. So you actually know a few calibrations already. You know this, and you know a calibration that looks something like this. Right? You know, basically, you know the height of it, and you know the flat plane of it. So the height of it, if that's 6, let's say that this is 2, I don't know. 2, oh, but this is 0, 0, and then this has to be 0, 6, and then this one is 6, like this. Oh, and then this is meters. So you know these two calibrations here. If you had a second camera, you could set up a box and get rough values about things coming in through here. But with the one shot and these two calibrations, you know things that are running in line with these planes. So if we see a particle going out this way or this way, we can use this calibration number 2 to find a pretty accurate speed value on it. If we have something going out exactly flat like this, we can use this calibration here to find a very accurate speed. So let's take a moment and look and see if we can pinpoint something doing that along either one of those.
Basically, there will be projectile motion, isn't it?
It's all in this, yeah, it's all in the setup of the object because everything is pulling off plane. But maybe we could argue that one of these ones here is more or less going flat along with the plane here. Like maybe we could argue that point 1 is sort of along the plane of this calibration number 1 here. You know, it's going out of plane a little bit, but it's not too bad. You know what I mean? Or this green one seems pretty good too.
Excuse me, Patrick.
Yes.
Yeah. So some of the particles may not be aligned with the movement along the plane, but if we calibrate two planes, not maybe not parallel, just inclined to each other, but we know the calibration of those planes.
Yeah.
And we know the particle is flying in between, somewhere in between along that plane. So we find information for that particle for those two planes individually.
Yeah.
And we get an average value for it, so that we know that yes, it's flying between. So some mean value, some average value.
Yeah, well, that's sort of what I was trying to get at with this, is if you came beforehand, and I mean, you guys know roughly the directionality that these are going to go at, right? They're going to go away from the impact point. If you put up a bunch of poles all over here, and maybe you have red ones that are over here in a plane, and you're going to use those for the calibration to do a plane, because you're expecting, this isn't great. You want to look at this rock crop when it blows out, and you're expecting it to blow mostly this way. Well, then beforehand, if you go in and you calibrate a plane along the projected motion line by putting in these poles or whatever you do, then you're going to have a very accurate thing. But you know, we use this software for a lot of really precise measurements. So we really try to dissuade people from doing it's just right. Like, we have people using this software to track missile trajectories where if it's off by a couple of centimeters, that's unacceptable. So we're always striving towards getting things within centimeters and getting super precise readings, which is why I'm being super cagey with saying that you can do this. You'll be able to get values out of it. It's just, you have to understand that when you get that value, there will be inherent errors, or there'll be a margin of error within the velocity values you're getting. I can give you a velocity value for these objects based on this calibration, but it doesn't, the error is going to be high. If you do something like this where you do a bunch of pre-measurements, you're still going to have error. The error is going to be much lower. There's always error. It's just, how big is the error?
So Patrick, those two planes we drew, can you go back to that figure that we have two perpendicular planes? Yes, this one. And we have the green perpendicular plane, right?
Yeah.
Yeah. Can you project it in the direction of that red plane, the XY plane maybe, the horizontal plane we have? Can we project the vertical plane in that direction, and like we will get the third plane also? Can you understand what I'm saying?
So this is, yeah. So this plane projects all along here. So I can track something that's over here if it's in this plane, right? So let me draw the bottom of this plane. It goes something like this, and then maybe because there's a dip here, it goes down here, and then maybe it goes up here like this. It's an infinitely thin layer, so maybe it goes like this, and then maybe I can't tell, but maybe it trails off into the distance like this, right? And it's this tiny thin layer that exists from there to there, and it goes infinitely high, or it goes as high as we can see it in here. So if there's a rock right here that flies straight up exactly along this plane, we can measure it to 100% certainty and 100% accuracy. If a rock way back here flies and goes whoop and loops over on the plane and lands exactly on the plane right there, yeah, we can totally measure exactly what's happening along that, as long as it's in the plane of motion. So anything outside of the plane of motion, all we can tell you with certainty is that we're uncertain where it goes. We can give you a value, but we don't know how close that's going to be. So in this instance, probably the closest thing on plane may be, you know, I can get you the velocity of this initially because it's right at the corner of the plane. So that velocity of this object moving is probably really accurate based on this calibration. But at this point, tracking it, it's off the plane, right? Unless, but I can't really tell unless this is blowing exactly out that direction away from it, but along the plane, then the velocity value for it is going to get more and more inaccurate. But right in around here, picking up the velocity of that edge lifting is going to be really accurate. And likewise, there's a bunch of blasts there, but if you pick up anything coming out along the edge, like the lift up of this edge, we can probably get that pretty accurate because it starts on the plane. But all we know about it is its inaccuracy would be increasing exponentially as it leaves the plane. So right in through here, if I just look at this area in these couple of moments here, we can probably get you a really accurate velocity of that. But the exact same objects out here, really inaccurate. Fair? Does that make sense? So if we wanted to pick up just that velocity right there, the initial velocity, we can do that right now if you'd like. So the way I'd do that is I'd come in here and I'd process this. And I'd crank the...
फेस हम लोग एक टॉप पॉइंट पे नीचे रखेंगे और हम लोग उसके परपेंडिकुलर नहीं हम लोग 2 मीटर का एक पोल बनाएंगे.
All right, let me adjust this.
वो पता है हॉरिजॉन्टल पता है ये पता है ऐसा करके ये वाला प्लेन में निकाल सकते हैं अगर हम लोग एक ही पोल बनाना. हाँ.
So I'm just going to do a bunch of 1D line tracking and see if I can't get you a decent velocity along this line. So I want all of these black and white apply here.
नहीं तो बस पहले लेकिन हटा देंगे पहले लेकिन हटा देंगे वीडियो तो कंटिन्यूएशन में नहीं है कैसे करेंगे वही ना बाहर से लेकर हाथ पे लगा के वीडियो हटा
and then so these calibration 2. So I'm going to use calibration 2 on all of these and see what values we get. But this should be quite accurate. speed, 2D speed. So here are the velocity values we get for this. So I would imagine, let me just filter these. I would imagine that these are really close to what they're going to be because it's pretty close to the plane that we're looking at. Let me just filter these so they're not all over the place.
प्लेन में रख देंगे, प्लेन में तो कुछ नहीं, प्लेन में रखना नहीं, कुछ भी ब्रेक करके कुछ भी रख देंगे तो मालूम हो जाएगा। आज बॉक्स रखा है, 4 बॉक्स रखा है, नॉन डिस्टेंस पर बोल
So I would think the velocity of this object is in around here. So, you know, probably in around the average of that, about, you know, 10 to 50 meters per second.
Can we smooth this curve?
Yeah, I could smooth them more if you'd like. So the reality is, you know, maybe that one, this point is jumping a bit. So we'd have to look for the one that has the smoothest transition. That green line seems pretty smooth in terms of, and they could be refined, but I think the green line seems pretty smooth in terms of the motion of the object going up. So it's saying it's between, you know, 12 meters per second. It spikes at 39 down to 0, 8, 14. So if we sort of average this line out, let's close these ones and just focus on that one. I could smooth it even more. You know, it's really all over the place. But that's where I guess the values would be, somewhere in between there, and that's based on slight amounts of motion in around the calibrated plane. You know, and I'd have to look at it more closely to make sure that it's not picking up something crazy, but that seems good. See, there's a dip down here where it picks up something different. Manual, if we bring the point up, and I just want to make sure that point is representative. Yep, seems pretty good. Yeah. Oh, okay, so here it goes crazy. It's picking up an object down there, so let's just move it up here. No, lock. So set that point there and bring it up here. You know,
Perfect.
something sort of like that. Set the point up here. So it's sort of following this sort of arc. And here I've lost it because it's gone down. But, you know, we could pick up a chunk, or I'd have to process it different. Refresh the graph. So I think that last little bit here where I did it is probably fairly accurate. You know, 16, 15 meters a second, something like that. The average over there is probably its speed. Okay. Now, if you guys want to experiment with that and come back to us, you can talk to our distributor out of India about doing that. I know he's done a lot of work with this in the past as well, so he can help you out more with that. What I'm going to do is I will send you a copy of this video that I recorded. I'll send you like a link where you can download this video. And I'll also send you a link where you can download all the files that I've generated in here. I'll just zip it all up and send it off to you. And I'll also put in some of the example files we set so that you can go through that. And I'll include the PowerPoint presentation as well, so you can go through that. In addition to that, if you have any technical questions that arise, feel free to email us. I'm always around on email, and I can shoot quick emails back and forth. I'm happy to help you in terms of that. There will be a fine line between emailing you with support and doing consultation work. I don't want to go too far into a consultation work on this, but certainly if you encounter any difficulties, or if you just need some quick advice on how you're setting up a calibration, I'm happy to do that as well. Okay? Thank you guys. Thank you guys so much for your time. Is there anything else you guys want to discuss?
Stabilization tool
How can we contact you in future? To the distributor or directly?
we can directly mail you, right? Anytime if we need some support, technical support.
Yeah. So you can email us at techsupport@excitex.com, or you can email me at phope@excitex.com. That's my personal email address. I believe one of you guys has that, I'm sure, at least, because you sent me an email yesterday on it. Yeah, or you can go through Vinoy if you want, and he can reach out to us as well. However you want to do it. If you have support questions, we offer free email and phone-based support for the life of the product. But it is support. It's not, it's not training, and it's not consultation. But if you want to do a little bit of that, or if you want to just shoot us a quick picture of what you were thinking, I'm certainly happy to email you back with a paragraph or two, or being like, hey, yeah, that looks great. I'd try it like this. Or if you need help with individual abilities or implementing multiple calibration fixers, I'm happy to help with that. Okay. All right. Well, thank you guys so much for your time. I really hope I really hope this was helpful to some level. I'm going to send